Okay guys, now it's time to figure out how to solve those problems. Let's use this one. The first thing you have to know is the combined gas law. The combined gas law can be written like this. P1 V1 over T1 is equal to P2 V2 over T2. It doesn't really matter what the units of pressure are, although they are usually atmospheres or kilopascals. It does not really matter what the units of volume are, though they are usually decimeters cubed or centimeters cubed. It does matter what the temperature is. The temperature must be in Kelvin in order for this thing to work. The first thing you need to do, like always, is to figure out exactly what you've got. The syringe initially contains 50 centimeters cubed. That would be V1. At 1 atmosphere, that would be P1. And 20 degrees Celsius, that would be T1. So, P1, 50 centimeters cubed. Oh, excuse me. That wouldn't be P1, would it? That would be V1. P1, 1.0 atmospheres, and T1 is 20 degrees Celsius, except that it's not, because we do not use degrees Celsius when we're solving gas law problems. Instead, we add 273 degrees, so that brings us to 293 K. What would the volume be if the gas were heated to 100 degrees Celsius, T2, whilst at the same time compressing the gas to 5 atmospheres, P2, which must mean that what we're looking for is the volume, V2. So, if we record that here, we've got V2, unknown, P2, 5 atmospheres, and T2, 100 degrees Celsius, except of course that it's not really. It's 373 K. Now we solve the problem. If P1 times V1 over T1 is equal to P2 times V2 over T2, if we solve for V2, my algebra teacher told me it would turn out like this. Now we substitute the things that we know, which again, my algebra teacher would have called this the plug and chug part. So P1 is 1 atmosphere, V1, 50 centimeters cubed, T2, 373 K, T1, 293 K, times P2, 5 atmospheres. V2 is equal to, so 1 times 50 times 373, close parentheses, divided by 293 times 5, close parentheses, equals 12.7304 centimeters cubed. Now, first of all, does that make sense? What would be the volume if you were heating the gas to 100 degrees, which would tend to make it expand in volume, whilst at the same time compressing it 5 atmospheres, which would tend to make it contract. So the overall effect of that is to make it contract. Now, how many significant figures do we have? Well, this one would seem to only have 1, but we can assume probably that it actually has 2, because this one has 2 and this one has 2. So let's cut this one down to 2. V2 is equal to 13 cubic centimeters. What happens when you're using the combined gas law and one thing is held constant? If we write down the combined gas law, and then we look at the equation, a glass syringe with 40 centimeters cubed of air, that would be V1, at room temperature, 25 degrees Celsius, that would be T1, is placed into a container of boiling water until the temperature in the syringe rises to 100 degrees Celsius, that would be T2. What is the final volume? That would be V2. Now notice that nothing at all was said about pressure. So let's see what happens if this thing is done under constant pressure. That's the phrase, constant pressure. That means that it does not change. Are there any shortcuts that we can take? Well, if we take the combined gas law equation and we solve for V2, we get the same thing we got last time. P1 V1 over T2 is equal to T1 times P2. But notice that pressure 1 is equal to pressure 2 because they were constant. And if pressure 1 is equal to pressure 2, then they will cancel out. And that will leave us with V2 is equal to V1 T2 over T1. So what do you get out of all this? Simply this. If you find something that is constant, you can simply remove it from the combined gas law equation. Then you're simply left with V1 over T1 equals V2 over T2, and you end up with this final equation. So let's go ahead and solve it. V1 is equal to 40.0 centimeters cubed. T1 is equal to 25 degrees Celsius, except it's not, because we don't use Celsius when we're solving gas law problems. It's equal to 298 K. T2 is equal to 100 degrees Celsius, except it's not, because it's equal to 373 K. V2 is what we're looking for. So if I take the equation that I've already developed and then solve it, I end up with this. V2 is equal to V1 40 centimeters cubed times T2 373 K divided by T1 298 K. The Kelvins cancel, and I end up with parentheses 40 times 373 close parentheses divided by 298, 50.067. Now I need to interrogate it for significant figures. This one here had 4. That one originally had 2. But we normally don't get our significant figures from temperature. We'll get them from the volume measurement. That was three significant figures. So therefore, our final answer will be 50.1 centimeters cubed. Now, be sure you try your hand at solving the two problems that are on the homework sheet. You'll find the answers at the end of this handout.